Hello, everybody. I will be shortly talking about the project DataBri-X. That is basically a bricks of data, so is a Lego of tools that we are going to play with. The idea here with the DataBri-X is that we have a collection of software tools, like they are doing different things, like data operations, machine learning, I don't know, face blurring, data analysis, and so on. So with this, then we have like a scenario or a process that we want to integrate these tools to each other so that they can collaboratively do something. And this something is going to actually realize a higher objective in accordance with a data-intensive project process. So basically, we have a process like this. So you are designing a process that first I will do some experimentation with data, then I will validate my data, and then based on that, I will do the actual analysis, and later on probably I will publish the results and so on. So with this general things and the toolbox, so the set of tools, the process, what we want to do is that if you have a process defined with an existing set of tools, how do you do some sort of a recommendation to show that, first of all, what are the tools that can best satisfy the requirement of those processes? And second, if you can optimize this for something. So here in the project, we are interested in optimizing for energy consumption. It's like that, for example, you have, like you want to do activities, like for example, in case of face blurring or number plate recognition, then there are multiple tools that can do this for you. So which one do you choose is based on your objective. And objective, if it's like for energy consumption, you will choose one tool. But if it's for performance, you will choose another tool. If it's for cost, you will choose another tool, or possibly you have no choice. So this recommendation is going to take the tool specification as input and the process also as input, and then produce a set of suggestion or suggested tools. Like, for example, this with the workflow. So we will suggest the tools and how these tools should be bound to each other to satisfy the requirements of your process. It doesn't guarantee that it will fulfill all the requirements, but it will do the best possible satisfaction or fulfillment. So in addition to that, as I said, there would be a set of policies that are coming to check and also to control your recommendation process. Here we are interested in optimizing for energy, as I said, optimizing for cost, and optimizing for duration of the execution of your process. So for this, then we will create a deployment package from those tools, bind all of them to each other as a workflow, and then you can basically run that on a cluster or something, all the tools ready to be used. So what is the relationship here with ontologies and knowledge graph and so on? Is that, let's say that the process we are developing a website that you go there, you design your process. So let's say, for example, here, you design the process. So let's say, for example, you say at the beginning of the project, I'm going to do data discovery. So I will have different sets of data sets. Then I will do some experimentation with those data sets to see if they feel the requirements of my project, if their quality is good, if they have enough attributes, and so on and so on. So you'll design all these things. And then in the second phase of your project, you say, okay, I will do this algorithm, that algorithm, this algorithm on top of that data. And then when I'm ready, I will publish it to somewhere, I will get a DOI, I will write a data paper on that, and so on and so on. So behind the scene, we know the relationship between these activities that you drag on your process surface and try to make the relationship with the tools that we have in our tool arsenal. So for this process that you saw here, behind the scene, there is actually a knowledge graph. For that knowledge graph, we are developing, actually this is started, to have an ontology that with this ontology, you can describe the process, the activities that should be done in that process, and also their dependencies, like in terms of data dependency and in terms of time dependency between them. Like for example, here you say is a process that this process has phases and has like working areas, which we call them disciplines, and then inside that there are different disciplines, there are different activities, and so on. So with this, any organization that wants to use this tool will actually use this ontology to create their own process. So with the website that I showed you, you can create your own process, or you can customize one of the existing processes that are in the repository of the tool. With that, when you are finished with the process, let's say this is an example. With this, you create your own, you customize it. You can also add phases, activities, and so on, but we will actually provide a set of templates for different types of projects. And then when you are done with that, inside each tool, we have like, in the consortium, we have like 20, 25 tools that are under development. But this will act as a marketplace for tools that can be reused under different licensing patterns. So in case you have a tool, you can augment the tool with this tool specification. That is another ontology, I will show it. You provide the tool, you provide the services, you actually explain the service in terms of an RDF TTL file, attach it to it, and send it to this web application. Inside that, we will actually create the cross matches between those services and what is on the processes. And later on, when someone wants to do something with the processes, we also include your tool or your service in the suggestions that are made by the recommendation engine. So an example of this one would be something like this. Here, what we are doing is basically like basic information about the software, basic information about the operations that the software is doing, and then relationship between this, that this is the duration of this operation, this is the time that it takes, this is the cost that it takes, and we have like a software benchmarking platform that we are measuring all the resources that are needed. Like for example here, we know that this operation, this single operation, will take 12 flops in terms of operating. It will take 10 milliseconds to run. It will take like, I guess, 1,500 nanowatts to complete. So with this information, the recommendation engine will use this to suggest you the tools that best satisfy the requirements of the process, and also optimize it for the objective that you have. Also, the resources that this operation will need are actually included in that specification. All of these things will be used by the recommendation engine and later on by the deployment engine. So when we are going to deploy this set of tools on the cluster, we will use this information to allocate resources to your workflow on the running cluster. So with that is, let's say, for example, here, the input to the recommendation engine would be one of these knowledge graphs, like a mini knowledge graphs, and mini knowledge graph about the tool specification, and the rest you already know. Thank you.
Thank you. So, any questions from the audience? Well, this was quite a complex topic. So your ontology that you built, is it built on existing ontologies like Profo, or did you construct the ontology yourself?
Actually, we have started from scratch, but we have placeholders to be replaced with the existing one. And Provo is one of them. SSA we are using for measurements. And what else? We use DCAT for like software specification and people specification and so on. That's it. So we start from like a built-in house-made ontology, but we just replace them with whatever that we find out during the project.
Okay. And if you're replacing those ontologies, the values you're computing, like the running time, that is quite dependent on the architecture that it's running on, I guess. So how do you provide the cost if you?
We have a sandbox. Every tool that we accept to be listed there should go into that sandbox and be measured. And then they are basically the relative information about it. So this is not 15 nanowatts. This is something we call it nanowatt, but it's like virtually normalized with the others on that sandbox. So it's not real value, but it's comparable value.
Okay. And the last thing, if you have a recommendation engine running, how do you optimize for not only for the energy consumption, but also for the, well, quality of the results? Because
we basically don't really care about the quality of results. We just optimize for what we know. And in this case, it's like we are doing multi-objective optimization using machine learning. Basically, we are applying reinforcement learning on top of that to find out. But the problem is that our data set is too small. So in many cases, we are just overfitting almost always is exact match. Mm-hmm. So
I'm always trying to figure out how to game the system. And so my approach would be to provide a tool that's very energy efficient, but does not produce any results.
Right. This functionality will be actually checked by another group in the consortium. So we have integration phases, we have functionality testing phases, and we have this benchmarking. But in general, that is right there, yeah.
Okay.
Yeah. That problem is there.
Yeah, the problem is there. Okay. Yeah, thank you.
Thank you.
Thank you so much.
Thank you.